Hello, everyone. My name is Alastair Robertson, and I'm the creator and co-maintainer of bpftrace. Today, I'm going to be talking about the ongoing work to make bpftrace into the ultimate tracing tool for Linux. Because, while today bpftrace is great for writing quick and simple scripts for most use cases, there are still times where it's necessary to create wrappers around bpftrace or to fall back to other more complex tools such as BCC or libbpf. So the question is, what can we do to make bpftrace suitable for these more advanced use cases? Well, we're enabling tracing for cases that were simply impossible before by adding new functionality and adopting new BPF features. We're exposing advanced options to writers of bpftrace scripts. We want to keep the simple defaults, but allow people to override them as much as possible. And finally, we're making it easier to write complex scripts through extensions to the bpftrace language. So we'll start at the beginning today with an example of one of the BPF features that we've recently adopted, the problems we've found, and how we've worked around them. The scenario here is that we want to trace a containerized application, specifically one which is running inside a PID namespace. Symbolication in bpftrace is typically done by recording a PID alongside an address. However, when the target application is running inside a PID namespace, we start to have problems. The standard BPF helper for getting a PID, bpf get current PID tgid, always returns PIDs as seen from the root or init namespace. This is fine as long as bpftrace is running in the root namespace. But if bpftrace is also running in the container, then we're not able to correctly look up the process using a non-namespaced PID. Enter a second namespace-aware helper, bpf get ns current PID tgid. So this one returns a PID as seen from the current namespace and works as long as bpftrace and the target are both in the same namespace. This means that it doesn't work for tracing containerized applications from the root namespace. Unfortunately, there's no single BPF helper which is able to work in all scenarios. And the workaround that we've put in place is to simply switch between the two helpers based on whether bpftrace is running in the root namespace or not. Now, there are still some more cases for which we can do nothing, when bpftrace is in a PID namespace, but not the same namespace as the target application. Ideally, there would be a single BPF helper which was able to translate PIDs between namespaces and that we could use all the time. But for now, our workaround to switch between the two helpers is sufficient to cover the most common use cases. Now, very quickly, in terms of making it easier to write bpftrace scripts, one of the major new features coming to bpftrace is user-defined functions. This adds a new syntax for enabling code reuse in larger scripts. Work is ongoing with an initial implementation based on inlining and plans to soon use BPF subprograms. And finally, I want to briefly mention some of the plans for userland tracing. I hope to make tracing userland applications with bpftrace just as easy as it is to trace the kernel. Some of the ideas for this are to increase the amount of debug data that we use, to better understand the data structures and stack traces that we might come across. I also hope that the ongoing work to add user-defined functions and BPF subprograms can serve a secondary purpose of allowing us to more easily interface with libbpf programs, which we could call into to get stack traces from higher level languages. So that's all I've got for you in this very brief overview today. To find out more, check out our website, our repository on GitHub, join the IRC channel, or come along to our monthly virtual office hours. Thank you all for listening, and I'll now be available for any questions in the Slack channel.